Hello everyone, myself Chandra Meena, and I'm going to present this presentation. The topic of presentation is operational challenges in machine learning model lifecycle. Let me introduce my team members. Vijay Agneeswaran, he is the director of machine learning platform team in Walmart Labs. Sarwesh Suman, he is a senior software engineer in machine learning platform team in Walmart Labs. And myself, Chandra Mohan Meena, I am Senior Software Engineer of Machine Learning Platform team in Walmart Labs. Agenda. I have divided this talk in these four outlines: background, architecture, analyzer, results. In background, I speak about our platform, basic introduction about it, and, and about the problem. In architecture, I will talk about at the engineering level what we did. Analyzer, we talk about machine learning model part, and in the results, I will explain what the business value we added from the solution. Background. Walmart Labs has built this machine learning platform around approximately 2 years ago. This platform has developed to help our data scientists. The platform supports end-to-end life cycle of machine learning model development and deployment. We provide all the tools and features which data scientists require to build a machine learning model from the scratch to the production. So we have lots of tools, like they can use various notebooks whichever they prefer, like RShiny, Jupyter. We have lots of libraries which they can use, and we use lots of deployment system where they can deploy their machine learning model. And most importantly, we also allow them to work in a collaboration manner, which is not possible if you're doing locally in a machine. So that's one of the most important point. The platform is a very useful for machine learning model development and deployment to production. As this platform was developed 2 years ago, we found that there are some challenges in terms of adoption. Like data scientists are not very keen to use this platform. They prefer to work locally, and they are not using platform as effectively as it was aimed for. So it was losing its main value. So to know the lax adoption of a platform, the first thing we generally do is we try to do survey. So about this I'm going to talk in next slide, that is problem statement. Problem statement. However, in spite of the expected utility of our platform to data scientists, we have seen many challenges in the evolution of our platform in supporting end-to-end ML model lifecycle. One important challenge is the inability of our data scientists to use the platform effectively. Therefore, less adoption of our platform is a key problem for us to solve. To address the challenge of adoption, we conducted a survey, and the general feedback of the users is that the platform is complex and not user friendly. There is a lack of clarity as to why the users claim the platform to be complex. Moreover, survey results are not always reliable due to social desirability bias. Therefore, for an objective assessment of adoption, We have decided to analyze the usage patterns of platform users and try to figure out the reasons for the same. As a user has claimed that our platform is complex to use, it was hard for our product managers to find out that what are the things he should make or introduce so that it become easier for them. So you can see that it is very hard to reduce actionable items or accurate details to make the system simple. And this complexity feedback was very generic. So we decided to break it down into two logical challenges: education and training, simplicity of platform. Let me explain what are these things. Suppose you are using some feature F and you find a challenge to use it. There could be at high level two reasons that you are finding it challenging to use. First, because you are new to that feature or functionality and you don't know exactly how to use. So maybe because you require a proper training or or documentation or videos to use that feature. So so that becomes a one education training challenge. So our aim to identify that what kind of features we think require a education training enhancement. Like what feature requires a better documentation, better video, and or better uh, documentation. Similarly, simplicity of platform. This challenge is I know the functionality. I know how to collect a data. I know how to uh, clean a data. But when it comes to use those things through the features, I find it challenging because that feature design is so complex. The UX is so complex that it is not very intuitive to where to click to do particular action which data scientists are already aware of. So we try to identify what kind of features could be or having the challenge of simplicity of platform. Let me briefly explain the architecture. So we have following ML life cycle, which is very common, like data collection, feature engineering, model training, model deployment. And we have tools and features which helps to do these kind of action, which help data scientists to do these things. Like for data collection, data cleaning, we have some features or tools. For feature engineering, we have another tools. So we have encapsulated these cycle into a platform. So we collect all the user actions and we try to classify all those actions to following class of signals: MLP error, MLP action, MLP time. And we use that data set to build a model which our analyzer use to identify that if this feature having this challenge or not, or if this feature have this challenge or not. I will explain these things in detail in the next slide. But uh, but these are the things which we have instrumented. Like so, in each model life cycle, whichever tool our user is using, we have trying to collect what actions they are doing, how much time they are taking to do that, and what are the errors they are seeing. And error is very important here to solve our problem. So collecting an error is very crucial. Let me mention here again, because most of the problem we have solved is using the collection of errors. So please note that, Please take a note of that. This is again just a briefly flow, like MLP is a platform, so there is an instrumentation service which store those into event repository, and there is a signal generator which read through those events and classify or tag them what kind of signal they are, and we use that data source to build our model and which model is using, and the analyzer uses that model. Analyzer Analyzer uses a user behavior segregation model and set of rules to evaluate challenges of using our platform. I will speak about the set of rules in the next slide. But in this slide, I will talk about how this model has developed. So, few things to point it out here is we have used clustering technique to build this model. We have clustered our users based on action and time signals. The features to build that model at high level, we have used like what unique features our user has interacted in platform. What are the unique resources they have interacted with? Number of projects they are part of. How many days they are active in platform. Average usage of in terms of time for each component in the platform. And number of time they interact with the feature. So these are the high level various features for our models, and so we used a k-means algorithm here to build this model. So we have used k-means clustering technique. The number of clusters were decided based on Salute score and later by looking at the cluster centered values. So the users in this cluster are labeled as beginner, intermediate, and expert. We have identified 85 expert users, 118 intermediate users, and 190 beginner users. Rule engine. This is the second part of our solution, and like we have created a groups using our model. Now we try to identify that if certain people from these groups, certain good percentage of people are seeing some error which are very obvious, then that may because then it gives us insight that these errors are repeating, coming so many from these groups, then it is because they are not trained to use, or maybe system is not so simple. That's why we are getting these errors. These errors are not system error, not caused by platform, but these errors because our user has done something which is not expected. Like for example, I can give an example. Like in our feature engineering stage, our users see lots of notebook, and suppose when they are working on the notebooks, and suppose I create a notebook, so it is active for certain duration of time, and if it is not, we are not using that notebook for certain period, then it becomes inactive. So the user needs to activate a notebook in order to open it. So but each user gets certain limited number of resources, so they cannot If resource is already used, they cannot create another resource. So there was no clear. So whenever some user coming and creating a resource in their project, so project is actually shared by lots of users. So when they're coming and creating that resource, and they are unable to create resource because resource is already used. So we get lots of error that uh, cannot create this resource because resource is not available. Like so many errors. So so this error has given us insight that we have to provide a better design so that they do not do this action. They do not repeat it. They should not because we found that around around 50% expert and 65% intermediate and 80% beginner users saw this error. So we realized that this error is something not required training, but it require show some information over there so that they don't click it. So that was a good insight. And so similarly, like that, we have identified lots of instances using these rule engines. So for example, one we found instance like in data collection stage, we have connectors which connect to lots of data sources and get the data for the users. So in your project, you need to create some connectors. So, but the project is shared by lots of people, so they have already created a connector. So sometimes users recreate connectors, though it is not required. They can reuse it, but it is not so intuitive. That action repeats so much that we identified that because of this action is so happening so much, we found that lots of users are creating same kind of resources so many times, especially beginners. And so we identified because it's not this simple. They require better training or documentation or video that how they can reuse the existing connector. So that's how this rule engine helps us to identify lots of instances. We have identified 17 instances of education and training challenge and 6 instances of simplicity of platform challenge. And this actually helped our product team to identify that what are those features which they need to improve in terms of effective video documentation or tutorials. So they have actually uh, re recreated lots of documentation after knowing that there are instances of education and training. And similarly, we identified some simplicity of platform instances. So that made our product team to deep dive that if they do some UX and UI change, whether it helps or not. So they are currently working on that and they are looking into it. So so to conclude that our analyzer here help us to make a data-driven decision to increase user adoption. Now we know that what kind of action item we